Hello, good morning. My name is Akhilesh Singh Kushwaha and I am a master student in Florida Atlantic University. So, welcome to the presentation on scalable trigger processing. Today, we'll be discussing about some of the motivation, challenges, proposed approaches, and contributions and their validations in terms of scalable trigger processing. So starting with the motivation. The motivation behind scalable trigger processing arises from the growing need for interactive triggers. For example, in the fields of internet programming and web user interaction scenarios, these triggers such as automatic email notifications and user engagement enhancements plays a crucial role in the modern applications. Uh, so for example, let's look automatic email notification flowchart and how it works. So first of all, the process begins when a user interacts with an internet-based application such as website or online platform. Then the user performs an action that triggers an event within the application. This event could be anything from submitting a form to making a purchase. Everything is done in this layer. And then once the application detects the trigger event based on predefined conditions or rules. For example, if a user makes a purchase of a specific product or exceeds a certain engagement threshold, then whenever it is detected, then the application automatically initiates an email notification process. This process involves composing an email message tailored to the specific event or user interactions. The process concludes after email notification is successfully sent to the user. At this point, the user may receive and interact with the email, completing the interaction cycle. And the another motivation behind this is limitation of current trigger systems such as scalability restrictions. We'll be discussing about some of the basic concepts before diving into the complexities of scalable trigger processing. Let's understand some basic concepts. So first one is trigger man architecture. So in this, the triggerman data blade, the core engine of the triggerman residing within the Informix database. It manages trigger registration, process events, and executes trigger actions. And then the data source applications represents local or remote tables in the database. For local tables, Informix automatically generates triggers to capture the updates and inserts them into an update descriptor table. For remote data sources, applications transmits update descriptor to triggerman via data source API. Then coming to the triggerman client applications that interact with the triggerman for various tasks including creating and dropping triggers, registering for the events, and receiving notifications when triggers are activated. Then coming towards the triggerman driver, it is the instances of the driver program periodically invoke a special function within the triggerman data blade called tman test. This function enables the trigger condition testing and action execution. Then coming to the triggerman console, a specialized application providing direct user access to the triggerman system. Users can create and drop triggers, start or shut down the systems, and perform administrative tasks through the console interface. Actually, this is the interface. So then coming to the trigger structure, this new trigger named T1 is activated when a new order in the electronics category with a quantity less than 100 is inserted into the orders table. So actually it logs a message into the order logs indicating low quantity electronics order inserted along with the order ID. And similarly, this is the same example I have taken. Then coming to the expression signature. The expression signature refers to the condition or event that specify when the trigger should be executed. So this particular example, this is the condition and which is nothing but expression signature. And then coming to the A-treat network. So A-treat network processing actually it is divided into three parts. First one is event detection and condition checks, and then efficient processing. So when in event detection here in the root, when there is an update operation or an order stable, trigger T1 is activated here. Then condition check. If a condition holds true for any updated row, the defined action is executed. And efficient processing includes trigger T1 efficiently process these conditions. This trigger T1 process these conditions, even the database handles increased volumes of orders and concurrent updates as well. So coming to the predicate index structure, this structure has two main reasons. First, I'll be discussing the purpose. The predicate index structure helps organize trigger conditions, making it easier to find and process them when needed during database operations. Then the components it made up of event conditions and when clause conditions. So we'll be discussing these. So first, predicate index root. Think of it as a main directory that leads to different folders of triggers. It's actually starting point for finding specific triggers based on when they are linked to in the database. Then data source predicate index. It is like a filing system for triggers. It actually sorts them by the tables or streams they relate to. This makes it easy to find right triggers quickly when event happens. Then the expression signature list, it is actually like a cheat sheet that summarizes the list of conditions which that specifies when the trigger actually needs to be executed. And one of the example I have taken here is this one. So here this one is the root and this one is the data source predicate indexes, and this one is the actual conditions for this. So this entire is nothing but a predicate index structure which consists of a root, then data predicate indexes, then their conditions. Then the last basic concept is trigger processing. So actually when an event occurs, the triggers are identified. Each trigger is then broken down into tokens hashed for unique signatures and grouped into signature list actually. Then selection predicates are added here to the tokens for activation conditions. Then after this, the joint predicates involving multiple data sources are processed, which means conditions that involve combining information from different places are checked here to make sure if they're all satisfied or not. When the condition is met, the trigger actions like data updates or any notifications are executed here. So this is a completely trigger processing system, flowchart that I have prepared for easy understanding. Then we discuss about problem definition and challenges. The primary objective is to develop a scalable trigger system. However, it has few constraints such as limited memory and a small number of distinct trigger structures. And the key challenges includes indexing for a non-equality operators, organizing constant sets, and optimizing trigger condition testing for improved performance. And and let's talk about the more challenges. Like the one of the main challenges in this arises from their computational complexities actually, as they need to process many trigger against updates. So it has to process many triggers for each and every update. So although it is not inherently NP complete, this presents significantly computational challenges. And then coming to the related works, so actually while there has been many research on active database systems and trigger processing, prior solutions often lack such scalability. Like in event condition actions, it lacks scale. It was not actually scalable. Then then again indexing. Like indexing strategies include range predicates and artificial intelligence. It has been explored, but there also it will be taking large memory and complicated storage because of the large data sets or large database, it would be a little bit complicated to store them. And last one would be parallel processing techniques have also been considered in the context of trigger processing, but there were like some issues in that. And let's discuss about the proposed approach. Although the paper presents a new trigger system designed to overcome the scalability issues seen in previous solutions, it takes a unique approach emphasizing efficiency with indexing and concurrency management and moves away from traditional query based methods. By doing so, it enhances the scalability and performance, particularly when dealing with a large data sets and concurrencies. Then the proposed approach. The proposed architecture includes several key components to address scalability challenges in trigger systems. These includes predicate indexing, trigger conditions, testing, and efficient data structures, scalable processing model, optimized algorithms, dynamic resource management, fault tolerance, and reliability. So, when coming to the indexing strategies, clustered indexes on constant attributes and alternative organization strategies for constant sets are employed to optimize the data access and retrieval. So these index strategies are used to optimize the data access and the retrieval. Then this trigger processing, which I have explained in the basic concepts, is actually streamlined through parsing triggers, converting conditions to conjective normal form, which is nothing but CNF, and build trigger conditions graphs for efficient evaluations. So this is used for that purpose. And so by integrating all these strategies, so architecture overview, indexing strategies, and trigger processing, this approach offers a robust solution to enhance scalability and performance in trigger systems, particularly for handling large datasets and concurrent or parallel operations, which was a limitation with the related works previously. When coming to the contributions, these contributions have collectively enhanced the efficiency, scalability, and adaptability of trigger systems, offering improved performance, throughput, flexibility, and extensibility for diverse application scenarios. So the first one, novel indexing strategies. Actually, it is an introduction of innovative index techniques to optimize data retrieval and reduce processing overhead. And the trigger processing architecture, it is actually a development of robust architecture for efficient trigger evaluations, enhancing system performance and scalability. Then the concurrent processing, it is actually implementation of processing methods to handle multiple triggers simultaneously. So like one trigger is running, then concurrently other trigger also, it will be easily smoothly, it will be simultaneously improving system responsiveness. Then coming to the improved performance and throughput, it is actually integration of optimized algorithms and resource management techniques to enhance overall system performance and throughput. Enhance flexibility and extensibility. It is actually a provision of increased flexibility and extensibility in trigger system design, facilitating adaptation to evolve requirements and technology integrations. Then the validations. The paper actually primarily relies on analytical evaluation to validate proposed approach with an emphasis on theoretical explanation to support design principles and strategies while lacking experimental validation. The methodology offers in-depth insights into scalability and efficiency. And there was actually no experimental comparisons in this. It was actually based on the previous works and theoretical analysis. It was actually implemented on Informix database. Then conclusion. So in conclusion, the need for a scalable trigger system is evident, and proposed architecture solution offers exciting opportunities for further development. So And the future works includes experimental validation and exploration of temporal trigger processing. So thank you everyone.